Hello viewers and welcome back to another video on networking. So in last few sessions we are seeing the ARP lectures on networking series, right? So we had an introduction, then why we need it and how it works as a basic session, and then we had an packet format video made last week, or you can also check out the links of those videos over here in the I button. And now in today's video, we'll see the simulation in CPT. So Cisco Packet Tracer, that has a lot of good stuff for us to observe how packets are formed and how we can actually verify packet formats that we have studied over here. So let's just start today's video with the CPT. So without wasting much time, let's get started. So as you can see, I have created a sample topology in Cisco Packet Tracer. Now, as you will notice that we are not in the real-time mode and we are in the simulation mode. And I can explain you the setup. First of all, I have created from the network devices under the switches, I have taken this 295024 switches. So this is a normal switch which has 24 ports, fast Ethernet 0/1 up to fast Ethernet 0/24, right? Now I have taken from the end devices 3 PCs and I have connected in such a way that PC0 is connected to, as you can see, if you hover over here, but if you hover over here, you will see the port with which this is connected to. So fast Ethernet 0/1, 0/2 and 0/3. As you can see, these three, when I hover over here, as you can see, the first 3 ports are link status are up, and you can also see the MAC address, right? Now PC1 and PC3, they are connected, and just to give you an overall idea for all this PCs, I have taken the IPv4 address from this address IP subnet, which is called 192.168.10.0, and 10.1 I have taken for PC0, and so on for PC2 and PC3. I'll just delete this packet from okay, and as you can see, for each of these PCs in the default gateway, I have taken the default gateway 192.168.10.100. Now right now we don't have any router over here or default gateway, but later on when we'll go for the next simulation, we'll see how it is important for us to configure default gateway. Now for the simulation, how we can observe the ARP packets is, we can just configure, go over here in the desktop command prompt, and we can, I don't know if you can see the fonts clearly, and I don't know if we can zoom this font. Okay, it's zooming the topology that we have over here, but let's just ping 192.168.10.2, right? So we will focus on this, and as you can see, we have this packet. So first, this is, as you can see the description over here, the ARP process construct a request for and target IP address. So since this is an ideal case, we don't have any MAC addresses for any of the IPs and any of the machines, even switches doesn't have any addresses. So if we just close this and if we just observe, so if you right click, okay, not sure, can we take a magnifying glass? Yeah, MAC table. As you can see, okay, it has all the MAC address. So as you can see, VLAN, all by default, all the ports are in VLAN 1, and as you can see, these are the MAC addresses. Now we can just observe this packet. So this machines doesn't have any MAC address for the target IPs that we are trying to ping. So it forms the ARP request packet, and the device encapsulates entire PDU into Ethernet frame. And as you can see, if we observe the fields over here, hardware type protocol, source MAC, destination MAC. So you can see source MAC is this and target MAC is 0. So as we have seen in the packet formats PPT or last video, you will see all this information. And this one is ICMP packet. So basically this packet is halt, and ARP request, this green packet will go. So let's click on the next. As you can see, green packet is over here. And as you can see, this is receives the frame, and next layer, the source MAC address was found in the MAC address table. Now it won't go beyond this point because switch MAC table has the destination MAC address. So now let's see what will happen. As you can see, the packet was broadcasted since the ARP request is broadcast, and straight away this machine rejected the packet, saying that the ARP frame is request, the ARP target IP address doesn't match the receiving ports. So we sent a ping to 192.168.10.2 and this is 10.3. That's why this machine rejected the packet, and this machine will give the reply. So we can check the next layer. Yeah, as you can see, the ARP request target IP matches the receiving port's IP address, and that's why we receive an information, we update the ARP table and we give the reply, and this is the outbound PDU. And as you can see, source MAC, target MAC and everything else. So target IP 10.1, which is IP address of this machine, that got selected. And now we can just proceed further with the simulation. And as you can see, this machine got the reply, and this ICMP packet is ready to be sent, right? And let's see now the black packet will go. This will the ICMP request reply this got, and in this manner 4 ICMP pings will be sent. This is the third one and this is the fourth one, right? And now, so as you can see, we have seen the first simulation. Now let's move forward to the next simulation that will explain you better way and how ARP requests and replies are formed. So we'll switch into simulation, I'll set up the topology and we'll see how the changes are looking. So as you can see on the screen, this is our topology, next topology that we'll see and observe the ARP request and reply packets. So right now, if you observe the MAC table, as you can see, it only has the MAC address of this fast Ethernet 0/4 of a router, and which is the default gateway for this network, which is 192.168.10.0/24. And it is also a default gateway. So this interface is default gateway for this network, which is 192.168.20.0/24. And the equivalent, okay, I misspelled the IPs, but the equivalent IP addresses are 192.168.10.100 and 20.100, right? Now, as you can see, let's observe first of all the MAC address table. So MAC table is this on the switch and this is on the switch. So both has the MAC address of this what you can say router interfaces, but it doesn't have any MAC address for this machines. Now we are inside the simulation mode, so we can observe the packet captures. Now let's first of all try to ping a device within this network. So let's try to ping a device this. So 192.168.10.1 will try to ping to 192.168.10.2. So let's try to command, let's go to and let's run the same command. So first of all, we'll see this packet is generated. So we'll go over here. Okay, so so this is directly creating the ICMP packets, since this machine last time got the ARP reply from this machine. So we can go to real time and we can just go to config desktop command prompt, and as you can see, we got the replies. But now let's try to go to simulation mode. Let's try to ping to from 10.3 192.168.10.3. let's try to ping 192.168.10.1. Yeah, as you can see, we have the ARP request. So this is ICMP, but the green packet is ARP request. As you can see, this is the ARP request. As you can see, ARP request for target IP address. Now let's see, this is going to switch will send the broadcast, and as you can see, router will also reject the packet, because let's see what is the reason. So the ARP request, the target IP does not match the receiving ports, because this interface of a router, it doesn't have the IP address 192.168.10.1, and this machine 10.3 192.168.10.3 is looking for the IP address, MAC address of machine which has the IP address 192.168 10.1, right? So this both of the machines rejected, and this will reply, and as you can see the switch will forward the reply, and now the ICMP packet will go, and we can just observe command term. That's how ARP request is sent within the network. Now let's try to see what will happen if we are trying to send ARP the ping into one of the device which is in this network, and let's see how the ARP request and reply is formed. So let's go into PC3 and let's try to ping 192.168.20.1. As you can see, the green packet, as always, it will be ARP request. So the device construct and PDU fast Ethernet sends out the ping, and let's now see what will be the destination IP for which we are looking for the MAC address. So as you can see, the target IP is 10.100. It is not what we have. So we are making a ping to 192.168.20.1, but as you can see, the target IP is 10.100. Now this is happening because this machine knows that the IP address 192.168.20.1, which belongs to the different subnet, and I mean that this machine knows because this is assigned an IP from different subnet, and we are trying to ping to a different subnet. So that's why this machine sends out an ARP request for the MAC address of the default gateway, since this machine also doesn't have an MAC address of the default gateway IP. So now let's see what will happen. So this machine sends the ARP request. Now switch will broadcast. These two machines will reject the packet because this machine doesn't have an IP address 192.168.10.100, but this router have, and then router will reply. And now all the packets, the black packets, they are ICMP request. They all will go via this router to this switch, and now this switch will again broadcast both of the packet, because this switch doesn't have any MAC address, for PC to reach to 192.168.20.1. So it will sends out an ARP request packet. This machine will prepare and reply, and now first packet will time out, and then these are few packets, STP packets, we can ignore those packets, and now timer will expire somewhere, and this second ping will initiate, and this ping will successfully goes through the PC3, and we can just go to real time and let's see the command prompt. Okay, maybe we can just. So the problem was that I misconfigured the default gateway. That's why it was sending an ARP request for the default gateway 20.11, and since that IP address is not there, every time we will try to ping this, it will say requested timeout, because we didn't have any from here. If we want to reach to here, we need to have an MAC address of the default gateway. Since the default gateway was configured incorrectly over here, we were not able to reach to this default gateway to be able to reach over here. But if I now go to simulation, now go to this machine, and if I try to ping, so from this machine I think ARP is resolved. So let's try from this machine to ping 192.168.20.2. So as you can see, the green packet is ARP request, and as you can see, the default gateway is resolved. Now first ICMP packet will be sent, and from here ARP request is sent because we don't know the MAC address of this machine. And now first ICMP request is timed out. Now second ICMP reply will initiate after some time from the PC1 over here. As you can see, the second ping is initiated. Now it will successfully reach towards the PC4 and PC1. Now if we go back to real time, if we open the PC1 command terminal, you will see first request got timeout, and now everything else is successfully got reply. So I think that's it for today's video. You might have seen the simulation of ARP packets, ARP request and reply. I hope you have got the idea about how the ARP request and reply are formed from switches, from the devices, and when they are formed, why they are formed, and how they are used when we are trying to ping the devices in the same network, and when we are trying to ping a device which is in different network but we don't have an MAC address of this. So that's how the ARP works and help us in the to resolve the MAC address for the IP address that we want to connect to. So that's it for today's video. We'll see you in the next one where we'll explore the same simulations in the NS3. So till then, keep learning and keep exploring. We'll see you in the next video. Bye-bye.